Hello, everyone. My name is Andre. I am working here in Unchained Labs product management, and I want to welcome you to our seminar. I'll be moderating, and we will have, of course, a Q&A at the end of the presentation. In order to submit a question for the Q&A, all you need to do is click the Q&A button in the Zoom navigation bar, which is either at the top or at the bottom of your screen. We will, of course, go through as many questions as we have time for at the conclusion of the presentation. Please don't submit anonymously so we can follow up with you afterwards in case we run out of time. Now, it is my privilege to introduce my colleague Brian Haldeman. He is the product manager for Buffer Exchange here at Unchained, and he will tell us about our latest instrument addition, which is Lil Tuna, and Lil Tuna's application in buffer exchange and concentration of samples. Lil Tuna is the first plate-based, fully automated, benchtop hands-free buffer exchange system, and I am excited for Brian to tell us all about it, and I think you'll be very excited to hear about it. With that, I'll hand over to Brian. Brian, take it away.
Great. Thank you so much for the kind introduction. I'm super excited to talk to everybody today about how you can get hooked on automated buffer exchange with Lil Tuna. So this may look familiar to a lot of people, especially if you live in California, primarily in the Bay Area. Traffic jams are something that, it's a true bottleneck when it comes to, commuting and traveling. So you can be traveling just fine on the freeway, around a corner, and everybody is stopped. So whenever I see this, I always wish that I could get into this express lane, right? Every time, so be able to keep moving. And this also reminds me of buffer exchange in the lab. And today I'm going to be introducing an instrument that truly is the express lane when it comes to buffer exchange. So we know that buffer exchange is truly critical for whatever type of lab that you're in, right? Whether you are doing formulation development with proteins and antibodies, whether you're doing viral vector design and having to concentrate very dilute viral particles, or if you're working with nucleic acids and having to clean those up before going on to downstream sequencing, storage, things like that. And truly, one of the things that we've been seeing lately is a lot of labs that are going more into high throughput. And when you do that, traditional methods just really don't keep up with that throughput need. So if you're using dialysis or centrifugation, these are both methods that are acceptable when it comes to doing small numbers of samples. But when you start to get into higher throughput, it become problematic, right? So dialysis is a slow method. Centrifugation, you have the risk of membranes clogging and inducing aggregation in your samples. And then with TFF, that is really more intended for higher volume buffer exchanges and can be complicated to both set up and also run. So Unchained has heard this problem from a lot of different labs, and we've continued to refine our buffer exchange portfolio. And today I'm super excited to show you about the latest release that we have, which is Lil Tuna. So Lil Tuna is a buffer exchange and concentration platform that is fully automated. It's plate-based, fits on the benchtop, and truly is that express lane when it comes to buffer exchange by being able to run up to 96 exchanges in a single run. So when we developed Lil Tuna, we wanted to make sure that we kept the things that worked really well with buffer exchange from Unchained Labs. And one of those is the consumables, right? Whether it's the plate-based Unfilters in the 96 or 24 well fashion, or the Una. All of these have a semi-permeable membrane on the bottom of them and can be used for buffer exchange. These worked extremely well, and we wanted to make sure that we were able to keep those and basically configure an instrument that could work with all three of those. So whatever your throughput need, we can fit that, right? If you need to do a high throughput run one day and then just run a few samples the next, Lil Tuna is an excellent fit for being able to do that. And when it comes to our consumables, we wanted to make sure that we kept all the flavors that we had before too. So the semi-permeable membranes, those can be of two different chemistries, and we have a bunch of different molecular weight cutoffs to truly suit any different type of molecule that you want to work with. Another part of buffer exchange from Unchained Lab that we decided to keep with Lil Tuna was our approach to buffer exchange, which is automated pressure-based ultrafiltration and diafiltration. So with this method, all you have to do is simply fill up your wells with your samples, whether that is in the plate or in Unas, and then Lil Tuna takes it from there. So we start by doing a volume measurement. So the system has an ultrasonic volume sensor inside of it, and we're able to measure each individual well and measure the true volume of each one. After that, we get into this iterative cycle that you see here. So we start by applying pressure and with mixing. And what that does is that forces the filtrate through the bottom of the membrane, keeping your sample retained inside of each well. After that pressurization cycle, we then measure the volume again, and that tells us, how much volume that we lost. That can give us a flow rate for each one of those. And after that pressurization cycle, and after we measure that volume, we can then refill with the buffer that we want to exchange into. So that's an iterative cycle that will continue until you reach your target exchange that you input when you set up the experiment. So once you have your exchange samples, we then can optionally do a concentration step, so an additional pressurization, to be able to lower that volume to effectively concentrate each one of your samples. So one thing that we really did improve when it came to buffer exchange and this approach that we use is the customizable pressure settings. So now you can choose any pressure between 15 and 60 psi to truly dial in exactly the right conditions for your specific molecule of interest. So one part of this process that I want to dial in a little bit further and focus on is that the pressure or the mixing that we do during pressurization. So orbital mixing keeps our sample nice and homogeneous, and that keeps the sample from building up against that membrane during pressurization. So dead end filtration, ultrafiltration, that's something that so with centrifuge tubes and when doing some centrifuge-based filtration, dead end ultrafiltration is something that you would see where your sample tends to build up against the membrane. We've gone around that and being able to avoid that from happening by applying this orbital mixing, and that allows us to keep that sample homogeneous, leading to more consistent and efficient exchanges. So these exchanges that we do, not only are they designed in a really well thought out fashion here that's already established from Unchained Labs, but we also get excellent results from it as well, particularly around the recoveries. So in this case, we're looking at an example of an exchange that was done in an Unfilter 96 and 96 replicate exchanges that were done of 10 mg per mil BSA. So you can see here we went to a target exchange of 96% that we were able to meet. And we also met the recovery target of greater than 96%. Also, we measured the diameter of that sample before and after exchange using DLS on our stunner instrument. And what that told us is that there was no significant effect to the size of that protein before and after the exchange, proving that we do have a nice, a gentle exchange that we're able to do here, and it had no effect on the quality of that sample. We can do the same thing with an Unfilter 24. So this is with our 24 well plate, and we did replicate measurements of replicate exchanges of IgG. So in this case, it was a 10 mg per mil IgG that we exchanged in an Unfilter 24. Once again, target exchange of 96%, and then recovery of greater than or equal to 96% as well. Once again, we measured the diameter before and after using dynamic light scattering on stunner, once again showing that we had no significant change in that size after the exchange. So one of the parts of buffer exchange that we did make some big changes to with Lil Tuna is how we do dispense and how we dispense those buffers into each one of our wells. And we really do have an accurate parallel dispense now to really speed that up. So instead of using pipettes, we now use peristaltic pumps. And that allows us to do parallel dispenses on up to 6 different conditions at the exact same time, making sure that this is still an accurate dispense that we can do. What we did here, the data that you're looking at is looking at a accuracy of different volume ranges, so anywhere from 25 microliters up to 8 mils. And we did this over a range of different viscosity samples, so water all the way through 50% glycerol, just to show that we were accurate in dispensing across a wide range of viscosity samples. Now, along that same time, we have that linear relationship to show that we do have accurate dispense. And also measuring the CV of each one of these samples, it was less than 1% at each one of these different volumes that we measured. So what that pump, the pump-based dispense, what it allows us to do is to really expand our capabilities when it comes to applications like reduced sample volume. So this is an application where, say, for example, you just purified an AAV and you would like to concentrate that down, because a lot of times those are quite dilute after you purify them. What we can do now is this reduced sample volume method on a much larger volume to start with. So you can start with 1 liter and reduce that down to 192 mils, which is essentially a full Unfilter 24. You could put your dilute sample into one of our buffer bottles, and what that will allow you to do is to use that to dispense into each well rather than an exchange buffer. So you can use that dilute sample and refill your wells with that, effectively concentrating into a smaller volume. If you'd like to, you can go even further than that 192 mils with an additional concentration step. And like I said, this is really most well fit for very dilute samples that are just after purification if you want to concentrate those down. Moving in the other direction, if you have a very thick sample, right? So typically, a lot of labs are doing some syringeability and developability tests where they want to concentrate their sample down. and see how well it behaves under the conditions that it would be actually used as a dosing towards patients. So if you start with a very viscous sample, what we can do is we can flip around a few of these steps in that buffer exchange process to make sure that our sample does not get too viscous from there, right? So instead of starting with a pressurization step, we start with a dispense. So you have your sample, we'll dispense our exchange buffer, and what that does is that limits how viscous that sample can get. So, once we essentially dilute our sample, then we can go through with the buffer exchange by pressurization after that. What that does is that keeps that sample from getting too viscous and make sure that we have a nice efficient exchange. We also did a lot of work with the software, right? So the software is super intuitive and easy to use. It's just a few setup screens that you need to be able to start your exchange. So those of you that are familiar with some other instruments from Unchained Labs, this looks very similar to our Stunner and Lunatic software. And what you can see here, we start in the top left where we can choose the type of experiment that we want to do, whether it's a buffer exchange, just simple concentration, or that reduced sample volume that I talked about before. From there, we simply go through our experiment info screen where if you're using one of our plates, the instrument has a barcode reader incorporated into it. So it simply just has to read all the information from the barcode. So you don't have to put any of this information in. It can simply go through and read that data from the barcode. From there, you just dictate what type of sample that you have, the concentration range, and then your target exchange. From there, simply go to the next step where we can paint our plate. So essentially, design where our samples are, where our buffers are, and everything is denoted here by numbers for the samples and then colors for the buffers. So you can design this either in the software or if you're working more high throughput, this is something you can use a sample template form as well and be able just to import that directly into the software. After that, you're off and running. So Lil Tuna will take it from there and be able to run your samples and do that exchange while you focus on other things in the lab. If you want to keep an eye on how that exchange is going, you could just keep an eye on the screen. And this is the progress screen that you can look at from the other side of the room. It's really designed to be easy to see from far away. So you can see, the current cycle, how much time is left in that cycle, total time left or estimated till the end of the exchange. And then we've color coded the plate here to determine, which one of our samples are complete and which ones are still, haven't reached that target exchange yet. So green ones have reached that target exchange, blue ones have not. Keep in mind here, if you have some samples that are flowing much faster than others, we also have incorporated a pause function. So if you want to stop that run in the middle, pull up the samples that have completed, that will allow you to, be able to process those samples more, with downstream assays while continuing to complete the samples that have not reached that target exchange yet. We've also made big strides when it comes to incorporating and integrating this instrument into automated workflows. So we've intentionally designed both the hardware and the software of the instrument to be able to integrate into automated workflows. For example, with the hardware, we have, the plate itself is readily accessible on top of the instrument to plate handling robots. With the software, we've designed a universal API software allowing it to communicate with other robotics in the lab. We have the sample input templates that I talked about before. And what this really allows the instrument to do is not only integrate into any automation workflow, but really into automation instrumentation as well. So for example, it can integrate directly into Stuntman, which is our automation system for setting up an automated lab. It's truly native AI. And it can also integrate into plate-based analytical instruments from Unchained Labs. So for example, Stunner and Auntie, both of these are, the sample format for those is a 96 well plate. We can keep the samples in that 96 well plate format between all of these different steps in an automated workflow. So truly Lil Tuna is joining this great lineup of analytics instruments from Unchained Labs. And really you can keep your samples, like I said before, into that 96 well plate format to truly have the most efficient 96 well plate-based buffer exchange and characterization workflow here. So like I said before, you need to do buffer exchange before any of these downstream assays. So it works really well and pairs really well with you need to do buffer exchange before determining concentration. You can do that on Lunatic. If you want to do concentration as well as measuring size with dynamic light scattering, as we showed before, you can do that with Stunner. Or if you want to measure with our all-out stability platform, Auntie, that will allow you to run thermal ramps and measure general protein stability for any one of your samples. So in summary, you really can get it all with one instrument when it comes to buffer exchange. Lil Tuna is fully automated, it's high throughput, It's plate-based and it's a benchtop buffer exchange system that really checks all those boxes to be able to incorporate into any buffer exchange lab. And like I said before, you can really hit that express lane when it comes to buffer exchange with Lil Tuna. And with this instrument, you have the wide open road ahead of you. No longer have to worry about those bottlenecks of buffer exchange in the lab. And with that, I would to thank everybody for joining this presentation today. And I would like to now entertain if there are any questions from anybody in the audience. I'd be happy to address those. Thank you so much.
All right. Thank you very much, Brian. Before we go on that road trip, first of all, thank you very much for walking us through how Little Tuna can be used for plate-based, fully automated, hands-on, hands-off benchtop buffer exchange and sample concentration with super high recoveries and without much hassle. I personally wish I would have had one of those when I was doing my postdoc and prepared samples for structural work. So much centric on
I
work.
spent a
And a
lot of
little
time in front of the
tuna
centrifuge,
would
right?
have
So
been great, right? Yeah, absolutely. Our audience has been super active and we have a bunch of questions. Before we start with the first question, the Q&A function is still active, so click that button in the navigation bar, top or bottom of your screen, and do submit more. We will get started on those now. First question, what makes Little Tuna different from Unagi and Big Tuna?
yes, great question. So I did focus on some of the aspects of buffer exchange that we kept, right? Things like the consumable and our approach to buffer exchange with the automated pressure-based ultrafiltration and diafiltration. But really what we've done with Lil Tuna is bringing all of those together, right? So compatibility with all of the different consumables. The pump-based dispense is another, big change that we made with the instrument that allows it to, not only dispense much faster, but it also sets it up to be integratable into automation workflows, right? So that's another aspect, with the benchtop size of it, it can fit into those workflows and be much more accessible to robotic systems, things like that as well.
Very cool. Thank you. Question, what is the final volume in a 96 unfilter and in an unfiltered 24 plate for concentration application? And how is the volume controlled? Actually, two questions.
Sure. Yeah. So the lowest volume, I think I'll address it that way. So the lowest volume that you can use in our unfiltered 96 is 100 microliters. So the range there is 100 to 450 microliters. So really anywhere in there is, what you can get down to. So we have determined, well, I guess I'll address for the 24 well as well. So the lowest volume for that one is 450 microliters. So the range there, 8 mils down to 450 microliters. So the way that we control that is off of basically intelligent algorithms that we can determine the flow rate of your samples during those pressurization steps. So we can vary how long we have those pressurization steps to make sure that our sample is, not getting below that lower limit and maintaining within that range of each one of the different consumables.
Thank you. And I think that also addresses the next question already. What is the throughput of the volume measurement for the unfiltered plates well by well? It's between 100 and, what is it? Say it again. For the unfiltered 94, it's 100 microliters to
450 microliters for the unfiltered 96. And then for the unfiltered 24, it's 450 microliters all the way up to 8 mils.
Very cool. Thank you. How is Little Tuna considered automation friendly?
Sure. Yeah. So the instrument is automation friendly, both from a hardware and a software perspective. Like I said, we've intentionally designed that plate to be readily accessible to a plate handling robot, so you can really set that up in a fully automated workflow. When it comes to the software, we've developed an API that's going to be universal and allowing it to communicate with any other robotic system. As well as, if you are working in high throughput in an automation fashion, you're not going to be setting up your samples individually in the software. So we do have those sample input templates that you can utilize to be able to, fill that up beforehand and be able to import that directly into the software too.
Very cool. Thank you. Some proteins are sensitive to aggregation by agitation or shear-induced aggregation. Have you tried this with such sensitive proteins?
We have, yeah. So we've done a lot of work lately with conjugates, and I think those ones are more prone to aggregation than just standard antibodies, for example. And one of the ways that we can get around that, if your sample is, especially prone to aggregation, like I said before, you can really dial in the settings specifically for your sample. So whether that is the pressurization that you're using, so like you can range, what PSI that you are applying pressure at. And also you can adjust the shaking as well, right? So that mixing that you're doing during pressurization, you can adjust the RPM of that. You can adjust the duty cycle, meaning, how much shaking you have during your pressurization cycle. And really, you can just dial that in, especially when you do have samples, as mentioned, that are prone to aggregation.
All right. So all in all, I think comparing it with a centrifugal device where membrane fouling and pressing a sample into a membrane constantly is an issue, you have a lot more parameters you can modify here, and all in all, is a gentler exchange. So for sensitive, aggregation sensitive proteins, that should be very well applicable.
Yes.
Users or one of our guests is asking, how do you define the percent recovery?
Yeah. So percent recovery is determined based off of, the volume that you're able to get out. And then that's measured via UV vis. So you can get the concentration of what's coming out as well. So that way you know what you originally put in, and then you can measure the amount that you pulled out at the end.
Okay, and that UV measurement, of course, happens in a photometer. And in our case, we mostly used a stunner, and that's also gave us the diameter reading, and we used the diameter as a quality control. This was the second half of that question, percent recovery and diameter. So this is just to assess sample quality post exchange. Procedural question: how does Little Tuna handle samples with different flow rates within the same run?
Yeah, good question. Inevitably, that's going to happen, right? Especially if you're doing some sort of formulation screen. Some formulations, your product is going to be more well behaved, and others not so much. So inevitably, that's going to lead to different flow rates. Now, when that happens, like I said, Lil Tuna does have this algorithm to determine to basically ensure that a sample does not completely dry out and making sure we're getting the most efficient exchange. So that is done actively during every pressurization step. So as we measure the volume at the end of each pressurization step, we can determine that flow rate and we can actually track how that changes throughout the exchange as you introduce more of that exchange buffer into it. Now, we can basically accommodate for that and be able to adjust on the fly how long those pressurization steps are. And then at the end of your exchange, as I mentioned before, as you're watching it, if some samples have reached their target exchange and others have not, we have that ability to pause the exchange, pull out the samples that have completed, allowing you to finish those ones that have not completed yet.
Thank you. Does this work best with all samples normalized to the same concentration prior to buffer exchange or concentration steps?
Good question. Yeah, so we do recommend that samples are similar concentration beforehand. I think that's the best way of predicting that samples are going to have very similar flow rates. So while we do recommend it, it's not necessarily required. But yes, we do suggest that people have very similar concentrations of their samples beforehand.
Although, of course, concentration as a parameter determining viscosity, that is like the final determinator, I think, for flow rates is what the viscosity of the respective samples are.
Yes.
Okay, there are a bunch of questions. I'm trying to summarize those. So, can you reiterate the molecular weight cutoffs and membrane materials? And is there any plan on, on expanding the variety of different membranes that we can offer?
Sure. Yeah. So I'll start first by explaining what the different membrane chemistries are. So we have either regenerated cellulose or we have polyether sulfone membranes. Right now, our molecular weight cutoffs are anywhere from 3 kilodalton that we have on the Unfilter 96. Then we have 10, 30, and 100 kilodalton for both the unfilters and with the UNAs. As far as additional membranes that are going to be available, I am totally open to that. So if there are specific membrane molecular weight cutoffs that you would like to see, if I see a trend, a lot of people wanting that, that's absolutely something that we can produce and basically respond to, the ones that are needed.
Cool. Thank you. The volume measurement in Little Tuna, is this done well by well?
Absolutely. Yes, it's done well by well, and it's done after every pressurization step. So that allows us to keep, real-time flow rates for each one of our samples.
Okay. Thank you. Having mentioned viscosity, is there a maximum viscosity for buffer exchange?
Yeah, so when it comes to maximum viscosity, we like to think in terms of actual, protein concentration for these. So typically, we recommend a max concentration for a standard monoclonal antibody at 200 mg per mil. That roughly relates, I know the viscosity can change for that depending on the sample and formulation buffer, but roughly, 50 centipoise somewhere in there in that range is really where the max is. And that's not really a limitation of the instrument itself. That's just a limitation of how long it's going to take to do the buffer exchange.
Very good, thank you. I think that kind of other question that goes in the same direction is what are the maximum concentrations? I guess that your answer
200
from
mg per
just
mil.
before
Yeah.
addresses that as well.
Yeah.
What is the care? What is the what does the user have to do about the instrument? Any extra care required? Like, do you have to clean the buffer lines?
Yeah, great question. So we've incorporated, of course, since we're doing this pump-based dispense, we have the ability to clean those lines after a run, right? So we have the ability to purge every one of those lines. So we recommend putting that into 20% ethanol and being able just to purge all those lines to make sure you don't get a buildup of buffer salts in those. That being said, over time, there is some maintenance required to be able to replace those lines. We've made that super simple for customers to be able to do in their own lab. And basically, we designed it in the software to be able to walk you through how to do that line by line.
Okay. What types of samples can be processed in Little Tuna?
Mhm. Yeah, so anything from proteins and antibodies, nucleic acids, or viral vectors. Really, those are the big three that we recommend that people do exchanging with on Lil Tuna.
Okay. Do all of the samples have to have the same beginning volume?
They do not. Yeah, so one capability that we brought into this instrument is to be able to normalize the volumes, right? So if you have a bunch of different samples, you can load them into your wells and then tell the instrument to normalize those volumes before it even starts the exchange. That's going to give you a more, consistent exchange between all of your different samples. But also that's not required either. If you have samples that are at different volumes, you just simply have to input the volume of each one that's in your individual wells, which can be done with the volume sensor and it will basically, tailor the exchange and the exchange conditions based off of the samples that you have there.
Very cool. And then follow-up question, is Little Tuna able to compensate the volumes if they are very different at the very beginning of the experiment?
Yes, yeah. So we have the ability to either normalize those volumes beforehand, or like I said, it will basically recognize and make sure that the samples do not go below that lower limit for the volume and be able to basically adjust the pressurization and the conditions for the samples to ensure that that doesn't happen.
Okay. And Brian, just for you to know, the questions keep coming in, so I'm going to keep on asking you.
Cool. Let's keep going.
The plate is fully open to air. How to avoid dust?
Yeah, great question. So actually, during the entire pressurization or the entire buffer exchange process, there's very little time that the instrument is actually or that the samples are exposed to air, right? So most of the time it's in that pressurization chamber where it is protected from the elements. That being said, if dust is a big concern for you, we have the ability, since the instrument is such a small form factor, you can put the entire instrument inside of a fume hood. That's one possibility you can do as well.
Thank you very much. What do we take next? Can you talk a little bit more about that concentration experiment? You mentioned that you can go from 1 liter to 192 milliliters. Can you just elaborate a little bit?
Yeah, sure, absolutely. So, reduced sample volume is something that we've had for a while, but like I said, we've really increased our capabilities here. So, basically, the way that you would do this, you would take your large volume of dilute sample and treat that like one of your buffers for a standard buffer exchange, right? So, you'd put it into one of the buffer bottles and use that to dispense into your wells. So, let's say, for example, you had 1 liter of that and you were trying to concentrate that down to what could fit inside of an unfiltered 24, which would be 8 mils times 24. So that would be 192 milliliters. So what you could do is basically fill up each one of your wells, apply pressurization that's going to concentrate the sample that's in there. So your dilute sample is now concentrated. And then you could refill those wells with more of that dilute sample that was, inside of one of your buffer bottles. So it's basically going through a buffer exchange, but you are using your dilute sample to refill the wells rather than using an additional buffer. So what that would do, that would take the sample down to 192 mils, and then you have the option to concentrate that further if you want to.
Great. Follow up to this, how do you handle a sample that is bigger than 8 milliliters?
Um, you can handle that a couple different ways depending on how much volume that you have. You can, of course, exchange over multiple wells. So if you have a multi-well plate, let's say, for example, you have 48 mils, for example, you could put that into, 6 wells in an unfiltered 24, or you could treat that in unas as well. So you really have the flexibility of whichever consumable that you want to. You could do that over multiple wells, or you could handle it with that reduced sample volume application that I talked about before. So if you can dispense your dilute sample from one of those buffer bottles into the wells.
Cool, thank you. This is a relatively specific question, but I think it is not too specific and applicable. Is there a way to saturate the membrane with the formulation buffer prior to starting your experiment, or do you have to put your sample onto a dry membrane?
Good question. So we actually recommend that you do pre-wet the membranes beforehand. So you can do that into, typically recommend it's in the buffer that your sample is already in at that point. But yeah, so basically the process is that you pre-wet those membranes before you actually add your sample to it.
Okay. Um, is the runtime similar to Big Tuna with similar parameters, or is it quicker, or is it longer?
It will be quicker. So basically, the biggest change here is going to be that mechanism of dispense, right? So instead of having to use pipette tips to move, 1 mil at a time into each well, you can essentially dispense up to 6 different conditions and 6 different buffers at the exact same time over your well, since we utilize those pumps. So that will be the biggest game changer when it comes to, the time for total buffer exchange. It's basically going to be massively reducing the time that it's going to take to dispense your buffers after each one of those pressurization steps.
Okay, thank you. Does the volume measurement use the same basic principle as in Big Tuna?
Use the same basic principle, so it's an ultrasonic volume sensor, but it is a totally different sensor that we use.
Okay. Can a 96 well plate be used to process fewer samples than 96? And can the unused wells be used for a different experiment?
Yes, they can. So if you want to run a partial plate, you can absolutely do that. We recommend that people run up to 2 different exchange processes on a single plate, right? So if you want to use half a 96 well plate at one time, you can use the other half in a separate exchange.
Okay. To go through what we have not yet asked. We've covered the, can you talk about the number of buffers that you can use in your exchange?
Mhm. Yeah, so the system has 6 different pumps. So you can run up to 6 different buffers. So 6 different buffer conditions. If you're doing a formulation screen, you could do up to 6 at one time.
Okay.
This is great with so many questions coming in.
Yeah, right. I'm just trying to hit the ones that we haven't yet got. When you say pull out the sample that are done, do you mean pipette out the samples individually? I'm talking about a case when some samples are done while others still going on. Thanks.
Yeah, so basically you have the ability to pause that run, and what it'll do is it will present that plate, allow you to go in there either, with the robotics instrument or manually by hand if you're not in an automation lab. You can pull that plate out, pipette out the samples that have completed, and put the plate back in, and it will continue with the samples that have not reached that target exchange.
Okay. Here's a one that we haven't had yet. How big is the instrument relative to Unagi?
Smaller. It is smaller than Unagi. If you are familiar with our other instruments from Unchained Labs, it is about the same footprint as Stunner.
Okay. Is there any limitation what kind of buffers you can exchange from or to?
I mean, a typical buffer for a biologics sample is going to be compatible. I mean, we measured everything up to 50% glycerol. So if you have a very viscous buffer, we can absolutely, accurately dispense that. Um, the things that I would say we are limited by is, high concentrations or, high percentages of an organic solvent. And the other thing you want to be careful with is high concentrations of detergent. What that could do is that can lead to bubbles and inaccurate volume measurements. But like I said before, we have ways that we can, mitigate those issues with accurate volume measurements by, uh, reducing the shaking and things like that. So I would say, high concentrations of detergent and high concentrations of organic solvents would be the biggest limitations. If you need to, talk more specifically about that, please reach out and we can look at that in a little bit more detail. So,
All right. I think we have two more that are more on the commercial and market hitting side. Is there a trade-in program for existing instruments?
absolutely. Yes, we do have a trade-in program. Please reach out to your local account manager and we can discuss those specifics.
And then what about demos? Demos of Little Tuna.
Yeah, so as I said before during this presentation, we have a lot of the same buffer technology or buffer exchange technology, right? So instruments will be available for demo in Q4, but if somebody wants to demo right now, we do have that option. You can basically use our current buffer exchange systems to be able to demo as a proof of concept for that. We're open to doing that as well.
Okay. And I think you've already touched on this, but just to close out the loop, since Little Tuna has a smaller deck space compared with Big Tuna, which is I think good because it fits on the benchtop, I was hoping to ask how many different buffers can I use to buffer exchange multiple samples in a single unfiltered plate?
Yes, yes. So since we are pump based with our dispense and we have 6 pumps, you can do up to 6 different buffer conditions or 6 different formulations during a single run.
Cool. And then we'll take this one as the last one. Is the membrane reusable?
Membranes are not reusable, so each individual well is one-time use. But like I said, if you are using just a partial plate, you have that option to use, the other part of the plate in a subsequent run afterwards.
Cool. That brings our counter to a staggering 42 questions answered. So
Fantastic.
Thank you very much for answering all the questions. Thank you very much for the presentation. Thanks to the audience for asking all these questions and being so involved in this presentation. We couldn't do this without you. Um, we always are happy to have deeper conversation with you. If you want to chat with us more about Little Tuna or about any of the other products we have, contact us at info@unchainedlabs.com or direct your browser to www.unchainedlabs.com. We always like to chat. We always like to connect. Thank you very much for joining our virtual seminar. Thank you again, Brian. Everybody have a nice day and bye for now.
Thanks.